All right, let's see if we can have a crack at question 3 here. Hopefully we'll be able to help out a little bit. So we've been given 3 different angles here. Sine of x, cosine of a, and tan of b. So 3 different angles. They're all in the first quadrant, which means they're acute. Now, the easiest way to try and deal with these is, although we could do the first one, I want to be able to do all of them. Let's have a look at what the other angles would be, because you can see here later on we're going to have to find cosine in terms of x. Oh, they're not there. They're going to give us a tan in terms of x. No, tan's only in terms of b. They're being nice. All right, but there is one rule we should remember, and that's sine squared theta plus cosine squared theta equals 1. Now that's just Pythagoras' theorem if you think about it. Here we've got a hypotenuse of 1. This distance, the horizontal distance, the x-coordinate we talked about just a second ago, is cosine theta. This y-coordinate must be the sine of theta, opposite over hypotenuse, that'll be sine theta. And if I do Pythagoras' theorem on that triangle, the square of on each of the sum of the squares on the shorter 2 sides equals the square on the hypotenuse, which is where that rule comes from. You can just substitute into this rule to find out what the cosine of x is and what the sine of a is. I'm going to show you what I think is an easier way, but I'll leave you to decide. I reckon you can substitute into that all day long and get it right, so I'm not too worried. But here we've got the sine of x equaling 0.3. So 0.3 is the same as 3/10. So I could just write this opposite side as 3 and the hypotenuse as 10. Remember, sine is opposite over hypotenuse. We remember that from SOHCAHTOA, don't we? Probably have vague recollections of that. I know your dad even remembers that one. He loves it. So if this angle is x, then opposite over hypotenuse, that would be giving me 0.3. That's going to let me work out this other side using Pythagoras' theorem again really easily. So I'm going to have 10 squared equals 3 squared plus, let's just call it a for now, a squared, so it's going to be 100, equals 9 plus a squared, 91 equals a squared, and root 91 is going to be the value of a. Don't need to worry about having negative square roots because obviously it's a side length. We're only interested in the size of it. It's going to be root 91. If you want to do that on your calculator, you can. I don't know if this is going to do it for me, but we'll find out. 91 to the power of 0.5, that's the same as the square root. So if you want to, you can use 9.5394. I'm not sure what the answers are going to do for you, but let's keep that in mind either way. Let's do the same thing with cosine of a equaling a half, 0.5. So the cosine of a, cosine's adjacent over hypotenuse, 1 over 2, and you might recognize this from the previous video as well. That's adjacent over hypotenuse, or if we stick it into Pythagoras' theorem, let's call this one y plus y squared. Then I'm going to get 4 equals 1 plus y squared, 3 equals y squared, and root 3 equals y. And we already knew that as well, so we can now replace that side there, the y, with root 3. Those 2 triangles are going to be useful to us. Let's neaten up and make sure we've got enough workspace here. You can always rewind the video if you need to look at that stuff, so that's all right. Okay, we've got the little bit of extra information we need. Now it's just a matter of figuring out what part of the triangle are we, what quadrant of the triangle are we in. Sorry, just trying to do 2 things at once here. Once we figure out what quadrant of the triangle it's referring to, we can just go back to these little triangles and get the other answers really quickly. So, up here with my unit circle, we know that the sine of x is 0.3. X is an acute angle, so there's 0.3. What would the sine of pi minus x? Well, here's pi. Pi minus x is going to go back the same distance, isn't it? They're both x. And you can see that the sine of an angle and the sine of pi minus an angle, well, they give me the same value, don't they? They're the same height. So that one is just going to be 0.3. Let's have a look at the next one. I'm going through this pretty quickly, so if you need me to slow down and explain it more, let me know and I will. Or you can just go back and watch it again and see if you can make sense. Here I want the cosine of pi minus a. So a is the angle that made cosine equal to a half. Well, I probably didn't make it steep enough, but let's pretend that's at 1/2. That was a pretty dodgy line. There we go. I made it the same angle, which means it's also not going to be really half, but it's close enough. See, we've got the cosine of a equals 1/2. What's the cosine of pi minus a? Well, you can see this is 1/2, and that's positive 1/2. But when I'm going back in this direction, even though the distance is 1/2, the value, because I'm to the left of the origin, is negative 1/2. So this one's just going to be negative 1/2, or negative 0.5 if you'd rather. It's all okay. Tan of 2 pi minus b. Well, we haven't... b, they seem to only be dealing with tan, so let's just go with that for the tan ones. So, if the tan of b equals 2.4, well, tan comes from the word tangent, so there's my tangent axis. If this is 1, well, I don't have all the room in the world, let's just call that 2.4 on my tan axis. So remember, that's a height of 1, so just double it, and 0.4 should be a bit higher, but that'll do. It's only to give us a bit of a glimpse of what we're doing. That's what the tan of b looks like. It's that vertical distance there on the tangent. What would the tan of 2 pi? So 2 pi is all the way around to here, and then minus b. I'm going to have to come back the other way. So 2 pi coming back the other way. Well, the distance is going to be the same distance from the axis, isn't it? This was positive 2.4, which will make this one negative 2.4. Again, you can get all the positives and negatives. I like to do it from the axes and understanding where sine and cosine are in relation to it. You can also get it from your all students take crack or something like that. That's what I've heard. I'm sure it doesn't happen at your school though. Cosine of pi minus x. Okay, so we're back to this x1 where the sine was 0.3. Let's rub it out and draw another picture. I'll just do a couple more from each of them and then hopefully you'll be right. So we know that x is the angle that made sine equal to 0.3. So x is about there. It's a pretty low angle, pretty acute. Cosine of pi minus x. Well, that's going to be the value. What's it going to be in relation to cosine x? Cosine x, started writing theta out of habit. Cosine of x is just that distance along there. This is going to be the same distance, but it's going to be negative, isn't it? So it's negative cosine of x. We can figure out cosine of x though, can't we? Because we drew the little triangle using sine x equals 3/10. We could find the cosine of x equals adjacent root 91 over 10. Or if we just divide that by 10, it's about 0.95394. Wow, bit of a mouthful. But there you go. Cosine of x, root 91 over 10, but it was negative because it was cosine of pi minus x in a negative cosine quadrant. So it's just negative, same size. Similar thing here, we're doing sine in terms of the angle A. So we go back to our angle A, see if I can get it a little bit more accurate this time. So angle A, well, we know it's going to be 60 degrees or pi on 3, don't we? Because that's one of the triangles we know, but there we go. We've got it there. Oh, did you see what I did on that triangle? Because I didn't draw it proportionally, this root 3 side looks smaller than that one. That's why the angle A here looks small when in actual fact it's 60 degrees. But doesn't matter because this is just to give you an idea of what we're doing. Sorry for the sidetracking there. Let's get back on track. Come on, Chewy. She's got an exam to do. All right. Sine of pi minus a. So here's pi. We're going to come back the same distance. Pi minus a. So in the second quadrant, sine is going to be positive. It's going to be whatever the same as the sine of a is. So that was pi minus a. We go to pi, we come back. It's going to be exactly the same as sine a. Sine a we can get from our triangle here, can't we? Opposite over adjacent, root 3 over 2. Just hang on a second, Lou. You didn't notice it, but that was just a short break sorting out, picking up and dropping off tomorrow. Sorry for the interruption. Last little bit to go here. tan of pi plus b. Well, b was this angle that went way up there, wasn't it? So that hit the tangent at 2.4. If I add pi plus b, it's going to be the same thing down this way. But when we're dealing with our tangent, we want to hit the tangent axis. You just extend the radius. So even though we're at that point, we always extend it back through the origin until it hits that tangent. So it's going to be the same as the tan of b. The tan of pi plus b will always be the same. Tan of b is 2.4, so pi plus b is going to be 2.4. And these all work exactly the same way. Let's see if we can speed through a couple more. We might do 3 more of them and leave you 6 to try yourself. Sine of 2 pi minus x. So here's 0 pi, 2 pi minus x. X was this little narrow angle there. Okay, so the sine, well, sine of x is that point there. It's 0.3. This is the same thing except it's below the x-axis, so sine is negative over here, or you get that from all students take calculus. That's what they take, not crack. I don't know where I got that from. So there we go, negative 0.3 because it's negative, but it's the same height away. It's the same distance. So that's all you have to do. Cosine of 2 pi minus a. Doesn't matter that I haven't drawn them accurately. I could just draw a like that. It doesn't really matter at all. Cosine of 2 pi minus a is going to be exactly the same as the cosine of a, isn't it? Because 2 pi minus a, it's still to the right. It gives me the same x-coordinate as just the cosine of a. We already know the cosine of a is 0.5 or a half. So this one's going to be 1/2 as well. Tan of pi minus b. This time we're going to be in the other direction. We go to pi and we go back to b, so it's going to be about that angle there. If I take away b, what do? I have to extend it through until it hits the tangent. That's not very well drawn. Excuse the bad drawing, but it's the same distance but in a negative quadrant, so it's going to be negative 2.4. It's the same as when we had 2 pi minus b, isn't it? That's why it's the same as part C. I'll leave you the last few to try. If you're stuck, maybe I'll do one of these 3 pi ones. Let's do n right in the middle there. Why not? And then I'll leave you a couple to do yourself. So cosine of 3 pi plus a, so there's 0, pi, 2 pi, so 3 pi is back around here, plus a, I'm going to have to go further. Cosine in this quadrant, so cosine's the x-coordinate, so it's negative. Okay, negative whatever the cosine of a is. Do we know what the cosine of a is? Yep, that's a half. So this will just be negative 1/2. All right, I hope that makes some sense. Watch it a couple of times, slow me down, maybe that might help too. I'm going to have a look at question 5. I hope this just gives you a bit more confidence before your exam. Cheers.